Tax Supply offers monthly webinars on a variety of topics throughout the year. The topic for today is Intro to NFPA 25 Sprinkler Systems. My name is Savannah Romans, and I'll be facilitating today's meeting. Please note, the information contained in this presentation is intended to provide general information, but not advice about certain regulations and initiatives. This is not intended as legal or other advice, and each situation may vary depending on the particular facts and circumstances. You should ensure compliance with your unique building, locality, and licensing considerations, and consult with your compliance and legal teams. And now please help me welcome Lee and Bob.
First of all, everyone for taking time to sit and listen to this presentation. I hope that you will find some value in it. NFPA 25, testing, inspection, maintenance of fire protection systems. Everything that's covered in this standard has to do with a sprinkler system, a wet type sprinkler system. We won't cover any special hazards, re-engineered, or anything of that nature. We're focusing mainly on the sprinkler system itself. Again, this is the 2014 edition. Currently across the United States, we're managing locations anywhere from 2002 to the 2020 NFPA 25 standard. It depends on which state has taken the initiative to adopt and update the standards in which they want their state to comply with. We'll be covering some things, how to prepare for the inspection, the responsibilities of the owner and the inspector, visual inspections, and then inspections specific to wet, dry, and freeze system inspection. The majority, just about all NFPA documents are laid out in a similar, at least through the first 4 chapters. It starts with the administration, which will cover the scope of the standard itself, the purpose, and what application should be used when you are applying the rules and regulations of NFPA 25 or the related standard. Chapter 2 is always the reference, through publications. So throughout the standard, if they are referring to, say, the replacement of a sprinkler head, there may be a note that would tell us that that reference came from NFPA 13, which is the installation of sprinkler systems. Chapter 3 is the definitions. Again, majority of the standards are laid out in this format, so it used to not be that way, but as NFPA has evolved, they have done everything they can to this, crossing from one standard to the other. Not seamless, but at least it gives you an idea of where to go and look for your information. Chapter 4 will be our general requirements, where we cover the responsibility of the owner or the designated representative, manufacturer's corrective actions, record keeping, water supply statuses, inspections, testing, performance-based programs, maintenance, and safety. Chapter 5 is specific to itself. The majority of Chapter 5 covers sprinklers, piping, more so sprinklers. That's the heaviest chapter for what we look for when we are conducting a sprinkler inspection. Gives us the dates and time periods a sprinkler can stay installed without any testing, and we'll cover a little bit more about testing of sprinkler heads in a minute. Maintenance and actions of component action requirements. Chapter 6, 7, 8, 9, 10, 11, 12, 13 are covering specific systems. When we talk about NFPA 25, we talk about it being the standard in which we conduct wet sprinkler inspections, whether it's a dry system or pre-action system that doesn't normally have water in it. The end result is we get water from it when we have an activation. Chapters 14 and 15 deal with 13. 13 is applicable to any system because it covers all the valves and components and trims, the corrective action, the frequencies in which it should be inspected or tested. And then we move into 14, obstruction investigation, and then 15, impairments. Impairments can be they can be very simple impairments where we're changing a sprinkler head, and it will go into how we should conduct ourselves, who gets notified, a plan of action, if you will, for a system that will be out of service. Scope of this first statement is very important to kind of latch on to. NFPA inspections apply to properly installed fire systems only. We have a lot of technicians that are out in the field and trying to redesign a system. They will send in deficiencies that say that we need to add sprinkler heads or we need to move sprinkler heads. What this section of NFPA tells us, or tells the inspector, it instructs us to inspect and perform tests on the system that is there. We are to assume that it was properly installed at the time that it was installed, that it was inspected by authority having jurisdiction to be deemed correct. So we don't, we should not be going in making deficiency reports telling you that we're going to change the sprinkler system. That takes evaluation from a qualified sprinkler designer, an evaluation of the facility itself. The exception to that would be when something is very obvious. If we go into a facility and we can see on the floor where a carpet strip used to be, where a carpet strip is not now because a wall has been removed. And by removing that wall, or that adding that wall, we have now created a situation that we can tell it should not have been designed that way. But even at that, we write that as a recommendation for the owner to have a qualified individual come out and take a look at that. The inspector generally is, they will be licensed, but they won't be certified design and inspection normally. Systems other than those which have been properly installed are beyond the scope of NFPA 25, meaning 25 is the standard for inspecting, not for installing. The visual inspection performed from the ground. When we go in and look at sprinkler heads, many times we provide a quote to correct. We found 5 sprinkler heads that we had that we could see. Since that inspection was conducted from the ground, once we get ladders in, have a crew in, many times we find that there are more sprinkler heads that that we were not able to see from the ground, and that you might receive a quote, a follow-up quote from a repair. It's very frustrating, I know, but that's how the standard was written. We don't want inspectors bringing ladders all through and trying to look at every sprinkler head. It does recommend in the annex that we use, if we have to, flashlights and binoculars should it be necessary on a very tall building, things of that nature. System failures. NFPA reports that the main reason systems fail to operate or fail to control a fire when you have an event is for failure to properly maintain the system. Most common reasons for system failures: closed control valves, lack of general maintenance, damaged system components, and the fact that 5-year internal inspections aren't performed. So On an annual inspection or a quarterly inspection, we're looking at gauges, looking at pipes, sprinklers, things of that nature. We look inside the pipe. We're looking for buildup, sludge, foreign objects, anything that could be in the pipe that would hinder the flow of water or could slide into the orifice of the sprinkler head that is discharging and prevent water from flowing. So that is some of the things that take place on the 5-year inspection. Reduced system failures caused by lack of maintenance, reporting damaged systems to the property owner. It's really what this whole standard is about, is to make sure that the system that is there, that is installed, is properly maintained, and we don't have components that are damaged. The owner has some skin in the game here. That the system has been properly maintained by licensed fire protection systems sprinkler inspecting contractor. Maintain drawings on site. This is very hard to do. Many of the sites that you guys have or other customers that we have would have been a building that was built 20 years ago, and the building came up for sale, and you bought the thing, and you don't have the as-built drawings. The standards say that those drawings should follow that building throughout the life of the building. So anytime that you do have the opportunity to gain access to drawings, it could be scanned in. If FedEx can do it, anybody can do it. They can scan those into a file for you and keep those on record as much as possible. Records shall be maintained by the property owner or designated representative for a period of 1 year after the next inspection. So basically, they're saying that record has to be kept for 2 years. All of our inspections we hold for the life of our customer. We have some customers that came in the door when I walked in the door, and we still refer back to those inspection reports sometimes when we're trying to figure out a problem that's going on with the building. So the longer time span we have with a customer and the more documentation that we're able to house and refer back to, the easier it is and the more effective we can be in making sure that the system is functioning properly and that unnecessary repairs are not being made or repairs being made twice. In this way that we look back through these inspection reports and repairs that have been completed, we can assure that you, the customer, is not paying for something twice. It gives us the ability to be able to save you money by not having duplicate repairs completed. Notify monitoring, insurance, and AHJ of the inspection. We have that International Fire Code is probably the most adopted standard out. The International Fire Code will reference different NFPA standards depending on what area we're looking at. And the International Fire Code tells us that we will inform the AHJ. Now, as far as the insurance company, that is not something we generally get involved with. And the monitoring company, monitoring has passwords associated with. We don't have those passwords, so that will be something when we show up, we'll say, can you please call your monitoring company and have them put this system in test. That way we don't flow water and have a fire department show up on a false trip. Contractor's responsibility is to review the inspection reports, compare the results year after year. When I walk into a riser room, if I'm conducting an inspection and hanging off of the riser, I've got a stack of tags, 30 tags maybe. I get excited because I can flip back and I can see what has been tagged, what has been commented about, even though I don't have the inspection report. when deficiencies exist, there are jurisdictions that even if a red tag has been hung on the system, they don't want the red tag to be removed. Rather, they want written on the back of it the corrections that were made, and then the compliant tag placed in front of that red tag that existed. 24 chapter 4 talks about the owner's responsibility to maintain as-built drawings and acceptance test records and shall be retained for the life of the system we were just discussing. This is to assist in the care and maintenance of the system. Perform visual inspection, visible sprinklers, pipe, and equipment. Test equipment per the requirements, per the requirements and schedules of NFPA 25. Paperwork. Always keep detailed records and include photos if necessary. In my department, where we're vetting the deficiencies, many times we'll ask for additional information. We may ask for a photo. We may ask for a return trip. We may ask for a second inspection. Generally, if I ask for a second inspection, that's on my dime. I'm doing that to make sure that what is being reported is validated by a second company. That comes as no cost to the customer. That's something that the department, my department, makes the decision. We are, that is on Cintas' dime, but it is a service that we feel is owed to the customer to make sure that what we report is being properly reported. About this, covers the sprinklers and the alarms, the pipe and fitting switches that will be on the system that will communicate with the fire alarm panel. We're looking at the hangers, and if we are in a seismic area, the seismic bracing, we'll look at that. Things become loose after years, and those are things that we're looking for. Number 4 is cut off. Let's see if I can. I apologize for number 4 being cut off. Water flow. Water flow is the water flow switch is either a vane type, which actually has a nylon disc that is the same circumference as the pipe. It sits inside the pipe, and as water flows past it, it causes that nylon disc to raise. And when it raises, it makes that contact point and closes the alarm circuit, which will then communicate with the fire alarm to central station to have fire department dispatched. And then supervisory, what we're talking about, valve required to be supervised, lock and chain, both. Sometimes it's just secure with lock and chain. In many different circumstances, AHJs play a big part in how a valve is protected. Obviously, the best method would be for it to be supervised and locked and chained. That's not always feasible to do, but that's one of the things that's covered in Chapter 5. About the inspection, we're talking about items in Chapter 5. Sprinkler shall be inspected from the floor. A sprinkler that shows sign of the following shall be replaced. If we see a leak from the sprinkler itself, and determine that the leak is not from a fitting above the sprinkler, but the sprinkler head itself, then that's cause for replacing the sprinkler. Painted, corroded, damaged, loaded, or in proper orientation. It seems kind of crazy to think about a sprinkler being installed in the wrong orientation, but we have replaced a sprinkler that was designed to be in an upright position with the going up, hitting the deflector, and having its umbrella come down, be installed in a pendant position. So what that's actually doing, the water is now shooting down, and the water pattern, the spray pattern is going up. So we're not getting that coverage umbrella that we're looking for. Corroded sprinklers, if you get a quote, or you can, as you are visiting your facilities, happens a lot around swimming pools where water softeners are, because of that are stored in those rooms. The corrosion happens at the seat of the sprinkler, and this is much easier if we were live. Hopefully one day we will have the opportunity to be live with each other on site, and I can show you. But what happens is that corrosion grows across the seat of the sprinkler. The seat is what holds the water back, and the glass bulb or the fusible link is what prevents the tip cap, is what it's called, from releasing to allow water to flow. As corrosion builds, it locks that pip cap into place. So even if the solder link does melt or the glass bulb does break, there is a delay in the operation of the sprinkler. It's called the RTI, the Reaction Time Index. And sprinklers are classified either as quick response or standard response based on their RTI, their reaction time. Painted sprinklers, there's two things that paint causes an issue with. If the paint is on the deflector where the little slits are, those slits are very specific in the design of that sprinkler, and it controls where droplets are that come from the head. If we're in a residential situation, we'll have a sprinkler head that will have very tight, very small gaps around that circular deflector. That's telling us we're going to get a very light spray of water across the area that sprinkler head is protecting. If you look in more hazardous area, warehouse storage or something like that, there will be very large gaps in between on the circular, again, deflector, indicating that the water, once it hits that deflector, it's going to be dispersed with larger droplets of water. So high challenge fires, fires that can get deep seated into something that's burning and become, fires are obviously hot. As water is coming down, if we don't put a droplet of water large enough, then it evaporates into steam before it gets to the core of the problem and starts wetting the materials that are on fire. Also, if paint is on the glass bulb or the fusible link, it acts as an insulator. Anything that will slow the rate in which temperature is affecting the solder link or the glass bulb delays the reaction time of the sprinkler. So two major things there with painting. Obviously damaged, if the sprinkler head is damaged, you could have a false trip of a sprinkler, or if the deflector, the round part of the bottom, if it's damaged, we're not going to get the spray pattern that we're looking for. Different orientations of sprinklers could be sidewalls, upright, pendants, and there's even a vertical sidewall. It'd be a sprinkler head that looks like it's pointed down in a pendant position, but the deflector will be turned out, and so the water hits and then sprays out sideways from that sprinkler that looks like it's pointed straight down. Last, talking about glass bulb sprinklers. If you've looked in one of your facilities and you look up and you see a red or a green colored liquid in the glass bulb, the coloring is just an indicator of what temperature range that sprinkler head is. The majority of your facilities, you're going to see a red colored liquid. That's going to be a sprinkler head that discharges at 155 degrees. Inside that glass bulb, there will be a little air bubble. And the way that the glass bulb is designed, as heat starts to build up around that sprinkler head at the predetermined temperature, that glass bulb will shatter from the air bubble expanding. the air bubble expands, there's nowhere for it to push this, and so it shatters the bulb. That liquid being gone, if something has bumped ahead and cracked that glass bulb, it's very rare, but it does happen. There will be no fluid in that bulb. And if a fire were to start up underneath that sprinkler head, it's not going to discharge. Glass has a melting point somewhere around 2,500 degrees Fahrenheit. And so you can imagine if your building is that hot, you've got some major problems, and that head still hasn't discharged. Chapter 5, do not look above tile ceilings. Now, these aren't rules that tell us that absolutely positively, if we're doing an inspection, we can't do these things, but to make sure there's consistency through all inspections. We talk about inspecting from the floor and other items. Again, this is the minimum standard NFPA, are the minimum standards. So it makes sure that we're doing at least the minimum amount of work to try to find issues within the building. Unacceptable obstruction to the spring. Usually we're talking about storage, whether it be a walk-in cooler or freezer, or it'd be a storage room when things get stacked too high. We need at least 18 inches for a standard sprinkler storage to stay at least 18 inches below it. The water pattern that we've been talking about, that umbrella effect, has time to develop without hitting an obstruction. Excuse me. Here it's chapter 2 being referenced materials. All inspectors should study 8 of NFPA 13, and NFPA 13 is the installation guide for sprinkler systems. We're doing a visual inspection for all pipe and fittings. Again, we're looking at that from the floor. Piping that is concealed is not to be inspected. Again, doesn't mean that we can't, but if it's concealed behind sheetrock, the standards are not requiring to cut sheetrock out or cut peepholes or anything like that to look at the concealed piping. But any piping that is exposed, we should be looking at that. It goes on in a different section of NFPA 25 to talk about when there are accessible areas to concealed piping and sprinkler heads, that during shutdowns or other instances like that, that's an opportunity that we can take to look in those concealed spaces, as long as we don't have to damage the structure to get to what we're trying to see. Reason for that is the concealed pipe and sprinklers are rarely affected by external tampering. I mean, nobody has spray paint, nobody's painted a ceiling and covered the sprinkler head over with paint. Here, there's the section. Pipe and sprinklers that may not be concealed but are inaccessible due to hazards that are inspected annually would be inspected during a shutdown. Hangers and bracing, we're looking just to make sure that, right, if a hanger has vibrated loose from from the beam clamp that is attached to the structure, the rod will cause it to swing around. So you'll have a hanger on the pipe and a straight rod sticking down. That's a very obvious sign that sprinkler pipe hanger has a deficiency, needs to be reattached or find out what caused it to fall away. The seismic bracing, we're looking for that to make sure that those are in place and tight. Last thing, that not inspect for proper installation, inspect for damage and fastening. Again, it's NFPA telling us, 25 telling us that we are not there to call out and say, hey, you need another 25 sprinkler hangers within the building. Just as an example, if pressure within a building is less than 100 pounds, then I can go up to 2 feet on a piece of pipe that runs horizontal over to a sprinkler head. But if the water pressure to the building is over 100 pounds, that lessens that 2 foot down to 1 foot. Now I have to put more hangers in the building. That is something you can look for without making the assumptions that he's going to change the design or make you do something that is outside of what the standard says that we're supposed to be looking for. They are to be inspected on a weekly and quarterly basis. They're also looked at on the annual. The weekly inspection, you are going to have us out every week to go look at gauges, but that is definitely something that is looked at on a quarterly basis. We encourage property owners to have a checklist for weekly inspection of their extinguishers and their water gauges and things like that. For E-lights, the push button, all those are planned maintenance items that are handled with the maintenance engineer or maintenance department for a facility. Same on dry. Gauges are to be inspected weekly there. Dry systems with supervised air inspected weekly. Dry systems protecting freezers, compare gauges at the compressor and above the dry pipe valve of the clapper to check for ice blockage in the airline. That's a little bit confusing for folks right there, but we're talking about when we have a dry system that is protecting, say, a walk-in cooler. The temperature difference between the cooler and where the air pressure is coming from, because of that condensation that would build up in our temperature, can actually freeze and form an ice plug in the piping. We can check our gauges because we have one on either side and compare what that air pressure is. If there's an ice block there, those won't read the same pressure or close to the same pressure. And that would be a key indicator that we do have an issue with some with an ice plug in the system. Flow supervisory signal initiation. This is something that is inspected quarterly for damage. It's also on a semi-annual inspection. We actually test these. So quarterly, we'll look for damage to the switch, whether it be a flow switch or a tamper switch on an OS&Y valve. And then semi-annually, we're doing a test on it to make sure it actually functions. Hydraulic design information sign. We look for that on a quarterly basis. Normally, the hydraulic calculations placard will be hanging from the riser on the chain. It's probably in the neighborhood of 4 to 5 inches wide and about 7 inches tall. That hydraulic calculation placard tells the inspector the criteria that was used when the sprinkler was installed. It will say that it was light hazard, ordinary hazard, high hazard, extra 1, extra 2. It will tell the water demand for the sprinkler system. So if we have a 100,000 square foot building, we still only design for a small area within that building to be protected at one time, meaning we don't expect the entire building to be on fire at one time. For a light hazard occupancy, we design for 1,500 square feet. So regardless of how large the structure is, If the fire grows beyond 1,500 square feet, the system is designed to handle that. So the fire grows beyond the ability for the sprinkler system to control it until the fire department can get there. That kind of reverts back to what we're talking about with the RTI, the reaction time of the sprinkler, from it being insulated from paint or dust loading or anything that insulates and delays the operation of the sprinkler. If the area that we have designed, say it had 12 sprinkler heads in it, and 9 of those sprinkler heads had paint on them, and instead of those going off, the heat flume passed by and started building outside of that area. Now we're discharging sprinklers that there may or may not be fire actually directly under them. Sooner or later, the dust loading burns off of this sprinkler, and this one discharges. Now the remote area we designed for 1,500 square feet, we have all those sprinklers going off, which would be great, exactly as designed, except for we set off 3 sprinklers around the remote area, and by doing so, we overtax the sprinkler system. So the cleanliness, the maintenance of the sprinkler heads, the changing of the damaged or the loaded or the painted sprinkler heads is a very scientific reason for requirements to replace. The sprinkler system is a very reliable system, but it has to be maintained. Valves we have to make sure that those valves are on so that when we need that water, we can get that water, and that the system is in good condition so that when a discharge occurs, it is in the right area instead of outside of what our fire area would ultimately be. The hydraulic calc plate, if you guys have buildings that you manage, anytime your buildings, go and look at the riser, go and find this plate, take a picture of it, and store it somewhere. And then when we send you a quote to replace the hydraulic calc plate because it's not on site, we couldn't find the as-built drawings to get the information for it, we have to reverse engineer that system, meaning the original time, we have to try to recreate that, find the remote area, take a new water flow test from the street, from the city hydrants, and then calculate through the system to determine if the system with the current water pressure will still operate as it was initially designed. Depending on the structure, that can be very challenging and it's very expensive. So if you see your calc plates at your facilities, when we send you the quote, you could tell us, hey, I've got a picture of that calc plate. I can send to you. We can return with that information and create a new calc plate without having to re-engineer the building or recalculate the building, rather. Very important piece of information. Most instances use it to the fullity of what it's there for, but a system designer does. He can go into that building. Our inspectors, we just want them to record that it's there and look at the pressures, the static pressure, meaning no water flowing. That information was recorded on the calc plate, and we can compare that to what is actually there now. And then if it has a large gap in between there, the calc plate says we had 100 pounds of water pressure, but when we're doing our inspection, there's only 80 pounds. We can show that as a recommendation, and that's something we do inspectors to do, is write that as a recommendation that there needs to be some further investigation to determine if the sprinkler system is still effective for the use of containing a fire. Following inspections or specific components or procedures will be found in their own chapters. Our valves and our connections to sprinkler systems would be 13. Obstruction investigations, 14. Impairments, 15. Hose connections would be 6. 6 deals with stem pipes. And then chapter 13 is valves. So every component within the building, in general, pipes, hangers, conditions of pipe fittings and things like that, condition of sprinkler heads, all that's going to be in chapter 5. But then when we get specific to the check valve, the fire alarm riser valve, the alarm valve, the fire department connection FTC check valve, we're going to go to 13 for the requirements for those items. I said we get a little bit deeper into sprinklers. Inspections is what we do when we walk through a building and we're looking to determine if the sprinkler head if the ceiling has sagged and it's blocking the water spray pattern, if it's loaded, if a wall has been removed and now you have two sprinklers too close together. From NFPA 13, it would tell us that the minimum distance between two sprinklers is, if they're closer than 6 foot, there's a condition we call cold soldering, where one sprinkler goes off and it cools the next sprinkler to the point that it won't discharge when it actually should be. That's called cold soldering. That's something we're looking for. This section, however, is not an inspection. This is a test. Sprinkler shall be replaced. A representative sample shall be sent to a recognized testing laboratory. Usually that's UL. UL has a place for heads. A head that is manufactured before 1920, if we were to find one, those are automatically to be replaced. If a sprinkler head is older than 50 years in age, we, instead of, in lieu of replacing all the sprinkler heads that are over 50 years old, we can send a sample at minimum of 4 or 1% of the sprinkler heads installed to UL. They will test them, and what they're testing them for is their reaction time. So standard response sprinkler, or if it's a quick response sprinkler, they're going to time the how quickly it reacts. If it fails its inspection, every head that's in the area where that head originated from has to be replaced. When we remove those sprinklers, immediately we attach a tag that UL provides, and we write down the date. We write down the location that it was taken from. And for each different area, and I'm not speaking about East Wing or West Wing, I'm talking about condition, outside sprinklers, inside sprinklers, sprinklers that are in colder environments, warmer environments. We have to send a sample from each of those areas, minimum of 4 or 1%, whichever is greater. That would be for the 50-year-old head. Quick response sprinklers came into existence in the late 80s, early 90s. At a 20-year interval, those sprinklers have to undergo that testing that we just spoke about with a 50-year-old head, but their frequency is much less. Instead of, now we're talking about 20 years. So if we got a facility that is greater than 20 years old and it has quick response or fast response sprinklers in it, then we are seeing more and more, because that 20 years just has really started kicking in in the last few years. A lot of companies still don't look for it because it would be new to a younger inspector, whereas an older inspector would have watched that progression and known that is to be. But at 20 years, we would have to send those off for testing. After the first 20 years, then every 10 years from that point, they have to be tested. So heads 40 years old, we would have tested at 20 years, 30 years, and then 40 years. Sprinklers shall be replaced or samples tested. UL, like I said, is generally who they go to. Over 50 years old are to be retested at 10 years intervals. When sprinklers reach 75 years, they shall be tested at 5 years. We talked about that 1920. Sprinkler manufactured prior to 1920 shall be replaced. No testing on those. Going into fast response sprinklers, 20 years, they'll be retested 10-year intervals. Sprinklers with a rating of extra high, which would be 325 degrees or higher, shall be tested or replaced at 5-year intervals and then retested at a 5-year interval. Dry sprinklers, these are going to be in your walk-in cooler and freezers, and if you have buildings that have outside sprinklers in a covered patio, porch, or whatever, it could be on an outside balcony, little area that the back door. I'm trying to remember your properties and apply it to that. But anytime we come across a dry sprinkler, that is a sprinkler that is generally 10 to 12 inches long. They can be to 47 and 4 inches long. And still we can UL approved to be used. You won't find a dry sprinkler over 48 inches long. Like I said, generally they're 12 inches. NFPA has put out a report that says that 50% of dry sprinklers that are sent into UL for testing fail their inspection. So unless you have many dry sprinklers, if we're talking about 6 to 8 within the facility, we're generally going to recommend you all 6 or 8 sprinklers. If we've got 100 sprinklers, we're not going to say every head they got to be replaced. We're going to send you a quotation to remove a sample, have them tested. Let's see what happens. You have a higher fail rate, and once we take that sprinkler out, it's destroyed by an UL as they test them because the operating element has been fused. There's no way to put it back together to reuse it, so a new sprinkler is put in its place. And then there says sprinklers exposed to harsh conditions, and the word dry sprinklers was left out of this particular bullet point. But dry sprinklers exposed to harsh conditions shall be tested at 5 years and 5 years intervals. We had some affiliates that were trying to on restaurants. Restaurants is a big vertical that we service at 99, our location in North Carolina. They were sending it in because in the annex, it talks about cold environments being a harsh condition. We reached out to NFPA, as we do many times, to get clarification of the intent of what the developers wanted to communicate. And a walk-in freezer that you would find for food preparation, a restaurant, or even maybe one of your dining kitchens, for your dining area, whatever. That's not what we're talking about. We're talking about cold storage, 20-degree storage, that type of harsh environment. Those would be tested every 5 years. Again, talking about testing, pressure switches, mechanical water flow detection shall be tested on a quarterly basis. A pressure, the same thing as a water flow switch, but a pressure switch would be installed on a dry system. On a dry system, we're not allowed to put the vane type that we slide that disc, we fold the disc over and slide it through a hole cut in the pipe when the system is installed. That it lays in there, waits for the water to flow so it raises up. If we put those on a dry system, what they found years ago, I can't even remember a time when it was ever allowed, so it must have been some very early on testing. When the dry system trips, pipes shake. You can feel it. You can hear it. It's just an inrush of water. It was tearing those nylon discs off of the flow switch. So when we have a dry system, we use a pressure switch that is mounted on the trim piping of the dry pipe valve. And when the valve trips, the clapper that was holding the water back, when it raises around the seat where it seals, there are little holes. So when that raises up, those holes fill up with water, and that water goes into an intermediate chamber, which goes over to a retard chamber, which is just a ball that holds water, and it prevents false trips from surges. And then it hits a diaphragm, and that's to hear about pressure switches. So it is the water flow switch for a dry system. You can look at it that way. Vane type switches shall be tested on a semi-annual basis. All testing shall be performed using the inspector's test connection. The exception that is there's a bypass connection that can be used if freezing conditions exist. So if we're doing an inspection and flowing water in a cold environment is going to cause an ice slick in the parking lot, they give us a provision to open an alarm test line that takes water to the pressure switch. The inspector's test connection generally will be located on the opposite end of the system from the riser. And what we're looking for when we open that inspector's test valve, we start timing. And within 90 seconds of opening that valve, the has to be notified. So we have to have an alarm within 90 seconds of opening the inspector's test valve. Systems. Annually, before the onset of freezing weather, the antifreeze solution shall be tested using the procedures outlined. There is a lot of communication, changes going on with antifreeze systems. We had an entire floor that was protected by a wet system, but we had a very small area outside. We could install an antifreeze system off of the sprinkler system, and we would some valve, some backflow preventers and things like that to prevent the antifreeze from mixing with the sprinkler water and diluting the concentration. Well, years ago, when we were filling an antifreeze system, we would take a hydrostatic test pump, a pump that we use when we are commissioning a system, and we would pump antifreeze and try to match that with the rate of water that we were filling the system with. The problem is you either get too much water or you get too much glycol. It wouldn't mix properly, so you would have an antifreeze system that would either be 100% glycol or 100% water, and you would still have a pipe that would burst during the winter months. And to that, it's flammable. We found that out when we started putting plastic pipe. It's most common name for it is Blaze Master. That's a brand name. That's not just terminology, but the Blaze Master pipe is one product that can be used in a light hazard area in some nursing homes and things like that. We'll see plastic pipe. Well, we started sprinkling houses about 15, 17 years ago or so. And in areas where it was subject to freeze, they would put antifreeze in them. But when the sprinkler heads would discharge because you had a small fire on your cooking appliance, the fire got bigger instead of putting the fire out. And they realized that the use of the glycol and an improper mixed solution actually did more damage than it did good, because we made the fire bigger, larger than what it was to start with. So they changed the rules, and they put a condition that any sprinkler system that was installed before a certain date in 2012, the antifreeze system was to be drained, solution, and had a plaque put on the wall that told how many gallons the system held, what solution was used, and what the freezing point was. UL listed solutions didn't exist, but NFPA wrote into their standards UL listed solution was not used by the year 2022, then you were no longer going to be able to install an antifreeze system. ICO this year came out with a UL listed solution. In the newer standards, the 2020 standard, it actually speaks to that. Some fire departments are mandating that if the solution is replaced, it's replaced with a UL listed solution. It's causing a lot of problems because it is almost triple the cost of what a non-UL listed solution cost in today's market right now. All that said is we're supposed to test. We want to test right before it gets cold. Make sure that any area that's being protected by an antifreeze system, we take a small sample of the water. We test it with a refractometer. We're testing for specific gravity to determine what the freeze point of the solution is. And in NFPA 25 in the annex, back in the back of the book, there's a chart of the United States with contour lines, much like you would see on a topographical drawing of land, but it shows the line moving through the United States, and it will be tagged with the freezing temperature. So if we were in and the city, and we followed the lines out, and it said that we had to be protected to 10 degrees, minus 10 degrees. When we tested that solution, we would go to the chart in NFPA 25 and see if the temperature, if the solution was good enough for the temperature that area would be subject to. And if it was, then it passed. And if it wasn't, it would be written as a deficiency. So a lot of things continuing to go on with antifreeze systems. We see a lot of quotes. Technician gets on site to test the antifreeze solution. He doesn't know what it is. There's no placard on the wall. He knows both of those are supposed to be present. And he writes it up as a deficiency. So we want them to, depending on what state we're in, that may or may not be a requirement, so we may not have to drain the system. It goes back to the fact that across the United States, we're working from the 2002 NFPA 25 all the way through the 2020 NFPA 25. Very, very, very frustrating, but that's something we do. We don't, the requirements in 2020 are what we have to do today. We look at the state we're in and then make our justification from there, so that you're not getting a quote that you actually didn't have to do to be in compliance with your what your state had adopted. Maintenance with when replacing a sprinkler, you replace that sprinkler with a sprinkler. The style, the orifice, K factor. The style is going to be upright, pendant, sidewall, vertical side. orifice and K factor. The orifice refers to the hole that's in the head, how much water is allowed to come through there. That's the orifice, and it has a corresponding K factor or coefficient. That coefficient is what we use when we're designing the system. So if it has a K factor of 5.6 and we replaced it with a K factor of an 8.0, we have changed the design of that sprinkler system. So that is something that we're not supposed to do. Temperature rating. If we take a 155 degree head out and all we've got on the truck is a 200 degree head, that is not a justifiable reason to change the temperature rating. You can have temperature ratings of sprinklers that are different. Say in a kitchen, right around the edge of the hood, we have a customer that was having problems. They were having false trips because we were reaching above 155 degrees for a very short period of time, but it was enough to discharge the sprinkler. Well, basically, you evacuate the building, you shut it down, you got a lot of cleanup to do, and our customers are spending a lot of money unnecessarily. So there's a chart in the standards that tell us how far away from a heat source we should be when we change to a different temperature. Again, there is a scientific or a fact, a way to prove out what you should be using in a situation like that. You just can't arbitrarily put a sprinkler head in place. Sprinkler heads are also, when they're engineered, they're designed with what we call an end head pressure. And that means the minimum amount of PSI that has to be delivered at that sprinkler head for it to operate and give you the amount of water and the spray pattern that has been listed for that sprinkler. So all these things have to be taken into account when you're replacing a sprinkler. To a situation where a Central Sprinkler Company, they were purchased by Tyco, but they had probably one of the largest recalls, I would say probably the largest recall in the industry for their sprinkler head that was designed with an O-ring as the seal. Would not, even though you would be gone, didn't discharge because of cause a problem with sticking the cat, not allowing it to discharge. In the case of a central sprinkler, we go back and find the original design criteria for that central sprinkler head and match it with another sprinkler head that's on the market, which is possible to do. It just takes some research, and that research has to be done to make sure that the system still functions as it was designed. We look for the spare head cabinets. Leland, bad again, please, sir. If we have a sprinkler system that has 0 to 300 sprinklers, there shall be no less than 6 sprinkler heads in a spare head cabinet, usually located at the riser. If we have 4 different types of sprinkler heads, but still have less than 300, 6 sprinklers really will not do what we're supposed to do. Type of sprinkler that's represented in the building, we should have at least 2 sprinklers to be at the ready to install in the case of a fire. They're there so that the correct sprinkler, we've just talked about the characteristics of a sprinkler when we replace, should be like for like. So 4 types of sprinklers, less than 300, I'm actually looking for 8 sprinklers, not 6. And it says 300 to 1,000 is 12,000 more, 24. That's what we're looking for. We're looking for 2 replacement sprinklers for each type of the building. And the reason why we're looking for 2 is NFPA through testing and over the years, reports that have been written on fires indicate that most fires are contained with 1 to 2 sprinkler heads discharging. If it's more than that, then you're going to be doing much more work, and it's not as important to be able to return that system right then with the spare heads. Each different type of sprinkler head, there are sprinklers that use the same wrench, but the majority of sprinkler heads have their own wrench, and each sprinkler has to have the correct wrench in that head box. Right here, it's still in the standards because there are still a few sprinkler systems that protect commercial cooking equipment. Just about all that has gone away with the adoption of the 300 standard, which says you'll have a wet chemical system protecting the cooking equipment, not sprinkler heads, but it still remains in the standard thus far. Okay. Covered a lot of material. I apologize for the poor connection. I live on the other side of the boondocks, so I hope you were able to hear most of what I said and take something from it.
We definitely were. Thank you so much for that, Bob. And now for anyone interested in learning how direct supply can help you navigate these regulations, please help me welcome Dustin Teske.
Really appreciate the support that Bob and Lee from Cintas provided. Hopefully this is really good information that's helpful from a service provider's perspective, one specifically that sits on those NFPA advisory boards for sprinkler systems, as to the things that they look for and as to the things that they're performing on their inspection as well. From a direct supply perspective, you've got a couple of great options available to help support these life safety code inspections or annual surveys as well. The very first one is our TELS platform. And for those of you that aren't on TELS platform today, stay tuned. There's going to be solutions to help outside of that as well. But if you're on TELS today, there's some great tools available within the platform to help manage your existing contractors and service providers against these annual or quarterly inspections for your sprinkler systems. Those of you that use TELS know that the best 2 features you're going to find is the work order efficiency, managing reactive versus proactive, and then specifically the regulatory compliance. And I want to touch directly on the regulatory compliance elements of TELS. So if you are a TELS platform user today, or if you're interested in learning more, you can understand directly how this applies to these life safety code standards. Within TELS, you'll find tasks as you see on the side of our screen here. These tasks are going to be oriented around proactive, preventative maintenance, best practices, or life safety code regulatory type events. You can find all of the best practices related to the NFPA standards or life safety code by underneath tasks. And we'll talk a few minutes from now as to how you find those. Specifically within the individual task itself, and what we're viewing right now within this portion of the screen is the actual sprinkler assessment inspection on an annual basis. Within the TELS task, you're going to find a couple different capabilities. Number one, it's going to give you the CMS Life Safety Code K-tag that directly relates to that annual inspection. Number two, it's going to provide guidance or resources on instructions to follow to complete that. Generally speaking, you're going to be outsourcing this to a service provider, but it's a great way to ensure that A, they're following the scope of work set by the NFPA, B, you have this scheduled and then completed within the timeline required by your CMS survey, and C, you can actually store your documentation right to this task. Your service provider is required by law to leave a physical copy of your inspection report on site. You can then download that document into TELS and store it right into this task as you resolve it. So on an ongoing basis, you're able to print off all of these life safety code tasks and provide them with documentation directly to your fire marshal or AHJ upon inspection. How you access that within TELS is 2 different ways. If you're a facility user, what you'll actually see when you first log in, again on the computer screen in the bottom left corner, is somewhat the screen that you first saw. I'll look at your work orders and tasks. By clicking configure, which is on the dark blue line directly above the light blue bar that contains all your different features within TELS, you're going to see a link called configure. If you click that link, you're going to see a drop down and it'll give you a few different options. Configure users. The one that I'm going to ask you to select is configure tasks. By selecting this, this is actually going to take you to a screen that provides all of the different tasks available as best practices or general rules of thumb for your facilities created by TELS. You can then search that by clicking filter by type, the second drop down on the right, to select the regulatory categories. And if you filter by ownership, all of the life safety code tasks are going to be selected underneath best practices. So, but once you enter configure tasks by clicking on the blue bar above the lighter blue bar, you're going to select regulatory, select best practice, and you can use the search bar or scroll down to find all of your fire protection or life safety code survey events, tasks to select and then view and manage against your facilities. If you're a regional or a corporate individual and your group has access to TELS, you can access this in a very similar way. The screens will look similar, but the first entry point is going to be different. As you enter TELS, you're going to see the TELS dashboard, which gives you an interactive reporting view of all your facilities that you have access and control over. Here, you're going to be able to track tasks as they're completed versus on time versus past due, and gives you a brief snapshot of the interactive reporting, what's going on within TELS, specifically tasks. By selecting configure again on the top blue bar this time, you're actually going to see the same sort of a drop down. Here you'll select tasks again. This will take you to the same selection screen, and you can filter by regulatory, filter by best practice. This will take you to all the life safety code tasks for fire protection on an annual basis. Again, the real value here is you can search for, select, assign to specific buildings. So you do not need to assign it to all your buildings. You can select which ones it's applicable to, and then manage on an ongoing basis through the IR dashboard to see the reporting results against that. If you are not a TELS user today, I highly encourage you to consider it. It is the #1 choice in building management solutions. With a network of over 13,000 users, by joining TEL, you'll gain access to best practice expertise from regulatory experts like those at Cintas, state surveyors themselves, CMS, CDC, other sources of regulatory guidance, as well as general best practices curated from the network itself. Take advantage of this for 3 different great solutions. Workflow optimization, managing your proactive tasks versus your reactive work orders, regulatory compliance, or just general asset management. To find out more, call 888-433-3224 or visit tels.net today to find out how we can start helping today for a very low monthly fee. Regardless of you're a user of TELS platform or not, there is a way to more directly control your fire protection program through TELS. Direct Supply has teamed up with Cintas to now offer a nationwide service provider network covering all service categories for all your fire protection annual inspections or test needs. Not only do we provide unmatched expertise represented by Bob Guthrie and the others at Cintas who sit on those NFPA advisory boards, but you'll access on a proactive basis reviews of your inspection reports, reviews of quotes or replacement repairs, to help, again, reduce the overall spend for your buildings, but ensure compliance across your portfolio of communities. Lastly, both Cintas and TELS have joined together with a service-first mentality. And if you've enjoyed the outrageous customer service you found from Direct Supply and TELS, you're certainly going to find that again here within this category. This also ties directly into TELS platform. If you are a TELS user today, your scheduling, your documentation will be managed through tasks similar to if you self-managed. But instead of your team doing it, it's taken over by the team at TELS, and we're going to manage the scheduling and documentation on your behalf. You should find 100% task compliance when you join the team at TELS Fire Protection. Oops. Secondly, the thing that we really wanted to note towards is this not only nationwide coverage for organizations with over 20 buildings, but you're going to see full category coverage. Many times you're working at an individual building with 2.8 or more service providers just to cover all the different categories you see on the right here in order to get complete coverage with your NFPA standards and your life safety code compliance. On the left side, what you're going to see is the annual report out of citations against those categories. And the reason we selected the sprinkler systems category today, as you can see, it is the #1 area of citation for life safety codes on an annual ongoing basis, and therefore something we perceive to be lots of questions or concerns related to. As noted by Savannah before, we'll be sure to make sure all the questions that come out of today's webinars get back into your hands so you can not only access this great information in the slides, but the questions and the answers from our experts as well. With TELS Fire Protection, you do have complete coverage from one source. You're contracting with TELS, and our team at Cintas is going to cover all of your buildings across all these categories, and including some secondary things such as backflow prevention, kitchen exhaust cleaning, and a variety of other things as well, fire department connections, fire pumps, so on and so forth, or if you did have a data center, your hazard suppression systems as well. Just know that available through TELS and Cintas, You've got access to a network of vetted senior living technicians that can support all of the categories of work. And really the value we want to provide to you through that relationship is, again, increased task compliance, owning the scheduling and documentation, the number one reason for citations, improved cost management, consistent pricing, consistent service levels across all of your buildings, and gained visibility and control. By routing all this through TELS and managing through TELS platform, your buildings, your regionals will get access to that information real time at their fingertips. We hope that you've enjoyed today's presentation, and I appreciate you taking this additional time to learn more about options through TELS as well. Thank you.
Thank you so much, Dustin. And then thank you again to our wonderful presenter, Bob. If you have any questions about future webinars, please contact us at webinars@directsupply.com. And then you can see any of our past webinars at directsupply.com/webinars. Have a great day.